So we have one more tool to review about radicals, and then we'll go on to our last lesson, which is solving radical equations. But the idea is this: is there's a bunch of rules in math with fractions. We know that we can't divide by 0. There's also a rule about radicals. We can't leave an irrational number. So it's important to understand you can't have an irrational number in the denominator. All right. So because of that, that means no radical roots. We got to get rid of those. There's a way to get rid of those. Okay. It basically is what we're going to do is we're going to multiply the top and the bottom by that radical root. So multiply top and bottom by that radical root. And what that's going to do is it's going to change the top and the bottom slightly, and it's going to get rid of a radical in the denominator. So for example, right here we got a radical root in the denominator. So if I multiply the top and the bottom by that radical number, that's going to eliminate that. Why does that eliminate that? Well, let's just take a peek here. So the top is 6 root 6, and then the bottom is the square root of 6 times 6, which is 36. And then we got 6 root 6 all over the square root of 36 is 6. One more here. You can see it gets rid of that, but we can also cancel some more. These 6's cancel. Final answer here for this problem is the square root of 6. Hey, that's called rationalizing the denominator. We'll do a couple practice here, and then we'll let you guys try one also. So in this problem here, I am going to multiply top and the bottom by the square root of 24. Top would be 5 square root 24. On the bottom, it's going to be the square root of 576. Hopefully you're seeing what's happening here. When we are multiplying these bottom two, this is going to now be 24 squared. Anytime we take the square root of a square, if this was written as square root of 24 squared, these cancel. So the square root of 576 is 24. And that's kind of the whole point. That's how we're getting rid of that root in the denominator. Now we want to go even a little bit further. So this problem is slightly harder. We're going to look at rationalizing this root, square root of 24. Think about that as the square root of 8 times 3. So 5 root 24. I'm sorry here. Well, I don't know what the heck. Let me grab this eraser. Sorry about that. We do not want to break it up like that. We want to break it up like this. 4 times 6. And so, because the square root of 4 is rational, that's 2. So this ends up being 5 times 2 times square root of 6 all over 24. Now before I multiply that 5 and 2, we all know that that's 10. But before we do that, let's take a common multiple out of here. So 24 is 12 times 2. These 2's cancel. So my final here is going to be 5 root 6 all over 12. Box it or heart it. Okay, so let's try another one here. Again, you can hit pause. You can try it on your own and then check. That's our first step. Next step here is just understanding that this is going to be 6 root 63 all over 63. Now we want to try to rationalize this root, square root of 63. So I'm trying to think about a perfect square that's a factor. How about 9? 9 and 7. So this is going to be 6 times square root of 9 times 7 all over 63. The square root of 9, grab a different color here. Square root of 9 is 3. So this is going to be 6 times 3 times square root of 7 all over 63. Now we could multiply the 6 and 3 and make that 18. Or we can kind of look at, all right, is there a common multiple between 18 and 63? And so I'll let you guys simplify that. There is. Final for this. I'll use a different color. Is going to be 2 square root 7 all over 2 square root 7 all over 7. Take out your common multiple. We're good to go. Good luck. Now, the idea about rationalizing the denominator comes in a couple different forms. Sometimes the denominator is a number plus or minus. So if it's a number plus or minus a root, our way of simplifying is slightly different. We're going to multiply by the conjugate. I'm going to show you what the conjugate is in a moment. So here, I'm going to show you right now. So the conjugate of 2 plus square root 7 is 2 minus square root 7. Okay? So these are what we call conjugates of each other. It's almost like we have a binomial going here because we have these two terms that we can't simplify together. One is irrational, one is rational, and so we're going to multiply by that idea. So shoot, getting crazy here. Okay, so we want to eliminate that root. We're going to multiply by the conjugate, and then after that, we're going to simplify. So I'm going to show you some examples of this and what this looks like. Something magical happens when we multiply these two things together. Basically, the radicals are going to disappear, and it's super exciting. But it's a way to get rid of a root in the denominator if you have this sum or difference of roots. So we got 3 examples. We probably will do the first couple and then let you try the last one on your own. And those that are at home, you can fast forward or pause, whatever you like. Okay, so here's this idea where there's a radical down here, but it's the difference of a rational number and an irrational number. So we are going to multiply by the conjugate. 8 plus square root 5. 8 plus square root 5. Okay, that means a little bit more work. So this top right here, think about the distributive property. So we're going to distribute that minus 6 to there. So that's going to be negative 48 minus 6 root 5. Now the bottom is a different story. On the bottom here, you're going to distribute for all 4 of these terms. So you're going to FOIL. You're going to have 8 times 8, 8 times root 5, minus root 5 times 8, minus root 5 times root 5. Okay, so we'll do that. I'm going to use a different color for that. And this is where something magical happens here. So 8 times 8 is 64. 8 times root 5 is 8 root 5. Now we'll go to the middle one. Minus root 5 times 8. It's going to be minus 8 root 5. And then the last one, minus root 5 times root 5. That is minus root 5 times 5, which is 25. And the square root of 25 is 5. So what happens here is these are opposites. 8 root 5 minus 8 root 5. They go away. And this one is the square root of 5 squared, which is square root of 25. And we know the square root of 25 is 5. So this is minus 5. This middle goes away. So the bottom number is 64 minus 5, which in this case is 59. So the top, let's just rewrite it. Top is minus 48 minus 6 root 5 all over, what we said it was 59. Final. Now we're looking for common multiples. If there's a chance that we can factor here and here and then cross out with a common multiple here, we'll do it. Otherwise, we'll leave it alone. Okay, another example. Multiply by the conjugate. Make sure we distribute, boom, boom. So this top is going to be negative 80. Plus 10 root 3 all over, and then the bottom, make sure you FOIL. 64 again, plus 8 root 3. Actually, I wrote that out of order. This first one is minus, my bad, minus 8 root 3 plus 8 root 3 minus square root of 9, 3 times 3. So let's simplify a little bit more. Top is minus 80 plus 10 root 3. And the bottom, I'll do it in blue here so you can see. So the bottom, these guys cross out, and this guy is going to be minus 3. 64 minus 3 is 61. Final. All right, one more. You can try this one. And like I said, you can hit pause if you're at home. You can fast forward, whatever you got to do here. Plus square root 2, multiplying by the conjugate. 5 plus square root 2. Take some shortcuts here. Top here, boom, boom, 10 plus 2 root 2. And then in the bottom here, we know we're going to get 5 times 5, which is 25. We know these middle terms are going to cross out, and the last one is going to be, we know this one's going to cross out with this one. Ooh, I actually did those wrong, my bad. This first one is plus 5 root 2, and then minus 5 root 2. And then the last one's going to be minus root 4. We'll simplify it, different color. Let's grab a different color. I like new colors. 10 plus 2 root 2 all over. These guys cross out. This is minus 2. 25 minus 2 is 23. Now, I know the fact 23 is prime, so that's why I'm not going to try to factor cross out. There you go. Good luck.